This is activity 4, choose your own solution. And this is the cool down activity for lesson 7, all, some, or no solutions. And this provides a nice summary of what I've been trying to show you on how to look at these different equations. So it says, what value could you write in after 3x that would make the equation true for? So what value do you write right here that makes this equation up above true for no values of x, all values of x, or just one value of x? So visually, what I'm doing is I'm separating out this equation into two separate linear equations. And I'm looking at what the graph of those linear equations looks like. What does the line look like for this side compared to this side? And so visually, on a graph, if I use this as the reference point, this is the beginning line, or the line I'm going to compare everything to. If I have no values of x that are shared with this line and another line, so this is number 1 here, so there are no values of x. What does that mean? I'm going to go through the details in a moment, but in the most basic sense, it means that you have parallel lines. And so we'll go through that. If you have the same line, so number 2 is all values of x, well, you're getting the same graph, you're getting the same line. So those equations, those expressions are equal, and you get the same equation on one side as you do on the other side. And if you only have one value of x that makes this equation up here true, that means that each side has an equation for a line where each line intersects. They cross, and it's the point at which they intersect is the common point, the common coordinate between both of those lines. So this reference line and number 3 here. All right, so let's see what that looks like. So no values of x. So this side is 3x plus 8. So I'm going to take this side. I'm going to write a linear equation in the form of y equals mx plus b. So the slope is 3. So it's the 3x, m is 3, and the y-intercept is 8. On this side, y equals 3x plus some value, and this value just has to be anything other than 8. So you're going to have the same slope, so you're going to get parallel lines in the end, but because you make the y-intercept something different than this y-intercept here, they're going to be parallel, but they're going to cross this y-axis at a different spot. So you get parallel lines. There's no common points or no solutions because there's no intersection between those two lines. So you get something like this. So in this case, this is y equals 3x plus 8, so the y-intercept is 8. For this one, same slope. So the same slope. If you, for every single unit along the x-axis, the length along the y-axis increases 3 times that. So it's 3x, 3 times the length along the x-axis. And as you work this out, you get 8 is not equal to 5. And so this is what the authors want you to do. And so you get down to 8 is not equal to 5. And so you conclude, well, there's no values of x that satisfy that. Because that's the reason for that is because this side of the equation gives you a y-intercept of 8. And this side of the equation gives you a y-intercept of 5. So they're not the same point. So there's no values of x that are shared by both of these lines at the same time. The second example is when all values of x make this equation true. So that means that on this side you're going to have 3x plus 8, and on this side you're also going to have 3x plus 8. And so we could end there. Well, so we've made both sides the same. Well, what does it look like visually? So if I take this side and I write an equation, linear equation, graph that line, and I take this side and write a linear equation and graph that line, they're going to be the same lines. They're the same equations. So you get the same equation. The graph is the same line. So whatever value of x you choose, both sides will always be equal. You're going to get the same line. So that looks like this. So y equals 3x plus 8. Over here, y equals 3x plus 8. Whatever value I choose for x, I'm going to get the same value for y. I'm going to get a point on this line. It is the same line, whether you look at this expression on the left side or this expression on the right side. And so you simplify this equation, you get down to 8 equals 8. Again, this is what the authors want you to do, and I want you to see why this is true. What's the connection of this to what we did a while ago with writing equations for lines? Y equals mx plus b. And the last one was just a single value of x, which makes this equation up here true. And so if you do that, you're going to have to put a value in here for this unknown that changes this slope. You have to have a different slope because the lines have to intersect. So add either positive x's or negative x's to change the number of x's that you have. So you're changing the coefficient, this number. So you're changing the number of x's, so you're changing the slope. Changes the slope. The lines will intersect at there's a single point, a single solution. You can also change the y-intercept. You don't have to. The points can intersect right at that y-intercept, but you might as well change that as well. So change the value added to something not equal to 8, changes the y-intercept. So what I chose to do is I added a negative x and I added 5. So this makes the right side 2x plus 5. So now we have 3x plus 8 equals 2x plus 5. So if you graph those, 3x plus 8, you get this line right here. And 2x plus 5, this has a different slope, so this is going to be a different angle. So eventually it's going to intersect. It intersects down here, and it's going to cross the y-axis at 5. This line crosses the y-axis at 8. And so the point that they intersect down here is the solution to this equation. So if I now solve this equation, if I work through and figure out what's the value of x, as I go through and solve this equation, I get x equals negative 3. That's the point at which they intersect down here. X is equal to negative 3, 1, 2, 3, and y is equal to negative 1, by the way. So if I want to figure out what the value of y is, I go back up to this equation here and I insert negative 3. I'm going to get a negative 9 plus 8. Negative 9 plus 8 equals negative 1. So that's the value of y. If I use this equation right here, or this side of the equation right here, if I use the right side, negative 3 times 2 is right here. 2 times negative 3 is negative 6, plus 5 is negative 1 as well. And so if I use this side, I get negative 1. If I use this equation, 2 times negative 3 is negative 6, plus 5 is negative 1. I get y equals negative 1 as well. So this is the common point shared between both of these lines. It is the only time that happens. It is a single solution for this equation right here. 3x plus 8 equals 2x plus 5. And I can see that if I separate this side out, make this a linear equation, graph the line, and separate this side out, write this as a linear equation right here, and graph that line. You can see the point that they intersect is x equals negative 3, y equals negative 1.